Okay, hello everybody. Thank you for joining us for the final session of today, where we're going to talk to Neil McGee, another one of the data park engineers, about the PARCview deviation detection tool. So this is a tool that you probably maybe seen on the previous user conference. We did a short webinar on it as well, and it's a tool to help people find on kind of a daily or a periodic basis what what's deviating in your process and letting those things trickle to the top of the list so people can find out. You maybe know that your process is not running as well today as it did yesterday or a week ago, but you don't necessarily always know what has changed or what may has changed. The purpose of that tool is to help that type of thing trickle up. So thank you for joining us, and please take this time to watch the presentation from Neil McGee, and I'll be back again to help him with question and answer. So thank you.
Hello everyone, I'm here to walk you through our new PARCview deviation detection tool. First, I'll give you an overview of what we can accomplish with this tool. Then I will go into an example of how to use it, and at the end there'll be some time for your questions. So I'm going to start you off with the simplest question. What is deviation detection? Well, it is exactly what it sounds like. When something changes, we want to know. For our KPIs and other key tags, we probably already have alarms or reports set up, but this tool tries to catch what falls between the cracks. Processes can drift over time, and small changes can go unnoticed. Things like miscalibrated sensors or sensors that have gone completely bad, if they're not used every day, can go unnoticed for quite some time. And these can lead to larger issues. So this tool tries to answer these questions. What tags have changed the most? What tag changes are most significant? And what tags have increased variability? This tool helps answer these questions through several statistical comparisons, each aiming to answer one of these questions, and it brings to the top the tags that have changed the most. All of these questions boil down to what changed and when did it change? These are the types of questions you might ask when something is going wrong and you need answers fast. So the first thing I want to show you is that you can quickly find answers to these questions even if you have nothing prepared beforehand. So here's the basic procedure of running through this tool. First, you select a list of tags like you would for any other PARCview display. You can then choose a downtime tag so that we can filter out time where the process is unsteady. We're aiming to perform a steady state comparison. You choose a baseline period, which is usually a longer period of time, maybe a week or a month, where the process was operating smoothly. And we treat that as an ideal version of the process. You then choose another period of time as the comparison period, which is a second period where you know or suspect that the process is having problems. Finally, you choose one of the statistics that we have prepared by which to compare the two time periods. With that, I'll walk you through these steps. We open up a new display, and this is what we see. An Excel worksheet with 3 panels and a new tab in the ribbon labeled PARCDD. PARCDD is an Excel-based tool that uses data normalized sheets to retrieve data. The first panel is where we add tags like any other PARCview display. The list of tags we choose for deviation detection is often quite large in comparison to other displays, since we often start not knowing where to look for the issue. As such, if we go up into the configuration menu and we go into the tags tab, we have options to bulk import tags. We can import tags from an entire process area, from a list of PARCview displays, or we can drag them in from Tag Browser like any other PARCview display. For now, we're going to add some tags from a Steam system display that we have created. This dialog just lets us know which set of descriptions we are going to keep, either the current descriptions in the sheet or the ones we are importing from the display. In this screen, we also have the option to import a process filter tag if we already have one configured. But our Steam system doesn't already have a filter configured for downtime, so we're going to have to create our own. After we have added our tags, we have several other columns that we can configure. First, we need to show hidden columns. I'll step back through the other columns in a minute, but for now we're going to focus on the filter columns. This is where we manually configure tags to filter out process downtime for analysis. The tags we are looking for to use for our filter are some Steam flows that indicate which machines are running. We will set a minimum Steam flow that indicates that a process is not acting under normal conditions. We add an X to the exclude column so that the data will be filtered from all tags, not just these two specific tags. This is the same format as the DataPark normalized data sheets. We will also set the rank for these two tags to A. Tags are sorted alphabetically by rank, so this action pins these two tags to the top of the list. We can refresh the sorting with the sort button in the ribbon, and we see that those tags float to the top. Next, we select a start and end time for our baseline period. We will choose last month to be the baseline so that we get a long enough period to get a good picture of the process. We then click the Get Base Data button to start calculating our average and standard deviation for this base run. This calculation goes pretty fast, but we'll still skip over it now for the sake of time. We can see that it took 117 seconds to calculate, and 5% of the time, one of our two filter tags was below its limit. We've calculated the averages and standard deviations over the last month for each tag. These statistics are calculated using hourly averages, which help clean up noisy data and speeds up calculation if PARCview is already running at your site. We can then hide the extra columns that we showed before, as they're really only needed during the initial configuration. Finally, we choose a new time period to use as a comparison period. We'll look to see if we can find any issues from yesterday. And then we click the next Get Data button. This calculation completes quite a bit faster than the last one, so we'll let it calculate. The baseline data filled in the left panel, and the comparison data will fill in the second panel. This time it took 13 seconds to calculate, and there was no data that needed to be filtered. Again, we have the average and standard deviation, and we also have the minimum and maximum values for yesterday. These are again based on hourly tag averages. In the yellow columns, we have our statistical comparisons. The first column is the simplest comparison, percent change, which is just the difference between the two averages divided by the baseline average. The tool sorted the values for us, bringing the largest relative changes to the top. Increases greater than 10%, the limit configured up top, are highlighted in red, and decreases greater than 10% are marked in blue. Here we can start to get an idea of what has changed between the two periods. We can see that these two tags here have had a dramatic increase from the baseline period to our comparison period. If we want more detail on what this change looked like, then we can highlight one more tags and select the trend button. This will bring up the two time periods side by side. On the left, we have last month's data, and on the right, we have yesterday's data. From this view, we can see that it was not a simple shift of the tag average, and we can get a clearer understanding of what this change actually looked like. Percent change helped us answer the question of what has changed, but we still might wonder if that change is significant. To answer that question, we can look at SD change. If we select the SD change column, we can see that the tags are resorted based on this column. SD change, or standard deviation change, is the change from the baseline to the comparison period divided by the standard deviation of the baseline. This is also commonly known as the z-score. Using 6 sigma as our standard limits, we have the limit set to 3 sigma, and we can see that the highlighted limit violations. These two statistics may seem redundant, with SD change always being the obvious choice over percent change, but percent change can still be useful if our baseline was only a short period of time where the standard deviations of the hourly average may not be truly meaningful. We can instead ask if the variability of any tag has increased. What tag has seen the largest increase in issues? We can answer this question with the COV change. For those who are not familiar, the coefficient of variation is the standard deviation divided by the mean. Here, the COV change is the ratio of the comparison period COV to the baseline period COV. If the COV ratio is greater than 1, then the variability has increased from the baseline to the comparison period. These are the standard statistics that we have set up, but there are also some additional ones that we can enable from the configuration menu as well. If we want to know which tag had the largest deviation from its limits, then we can use the limit statistic, which looks at the maximum and minimum values for the comparison period. Limits can be manually entered in the tag configuration columns, or they can be imported from PARCview in the Limits tab. If we want to know which tag had the greatest variability relative to its specification limits, then we can use the CPK. The t-test statistic runs a t-test between the baseline period and the comparison period and returns 1 minus the p-value. This is the probability of measuring a difference less than the actual calculated difference if no process change has actually occurred. What this actually tells us is very similar to the SD change, but it takes into account the standard deviation of the comparison period in addition to the baseline. The additional stipulation here is that the comparison period must be long enough that the standard deviation of the hourly averages is also meaningful. I'll go into more detail on the remaining two statistics at the end of the session. If we go ahead and calculate statistics for a new comparison run 2 days ago by hitting the minus value up top here, and wait for this calculation to run as well. We will see that the new set of statistics shows up in the center pane, replacing the original comparison period. And in the right panel, we see both comparison runs side by side. We can pull in several time periods using our built-in run selector as well. It is not as fleshed out as the PARCview run browser, but it should have a familiar interface if you have used the other. For now, we'll set it so that it pulls in data for each of the last 10 days. This creates new columns in the right panel, but it doesn't actually calculate the data yet. We have to highlight those columns and click Get Data again. This will take a little bit longer to calculate, so we'll skip past this again. Now we see the last 10 days of comparison side by side. The coloring of the limits allows us to pick up on some trends that it would have been harder to see otherwise. And this gives us an idea of when something might have changed. As we can see, which statistic is selected. If we change the statistic that is selected, we see that it changes which statistic appears in the right pane, in addition to the sorting changes. One of these statistics that we've already looked like is likely to bring to the top the tags that we are looking for. However, it also may bring to the top other changes that are trivial or unimportant. If we have pulled these tags from other displays that we already know have important tags, then this can help remedy the issue. However, if we have imported all of the tags from an entire process area, we might have imported many tags that are less important to the overall process. To combat this, we can use some of the built-in tag sorting features. If we have identified a specific tag that is unimportant to our analysis, we can mark that tag with an X in the rank column, so that it sorts to the bottom and does not calculate. Alternatively, we could have deleted this tag entirely by highlighting the row and clicking Control Delete. After we click sort again, we can see that it is moved to the bottom. More generally with sorting, we want to sort the tags so that the important tags are near the top and less important tags are still available if we want to look at them, if the more likely culprits to our issues do not seem to be guilty of causing the problem. We can continue to rank these tags manually, but in the tag configuration tab, we have some bulk sorting options that we can use. First, we want to assign all tags a default rank. We will go with B here. Tags that have had very little variation within the baseline period are less likely to be important since they are well controlled, but we may not want to delete them entirely because any changes these tags do have might be significant, so we can just lower them to rank C. Valve states may be something we want to keep track of, but we may want to keep them in a separate section. We know our valve tags end with .out or .valve, so we can change the rank of any tags with that in the tag name. Some state tags, like valve open, closed, or a pump running, not running, can be useful, especially because we are using hourly averages, but we may want to move them to a separate section as well. Finally, if we have any tags that had no data during the baseline period, we can assume that those tags are not behaving properly and set them to X so that they will be sorted to the bottom and not be calculated. We can now see that our tags are all sorted alphabetically by rank. Each rank is still individually sorts with the greatest tag changes at the top. You can see if we move down sections that we have greater changes in each of these sections. If our initial search through the top section doesn't reveal any tags that could be the root cause of our changes, then the lower ranked tags are still there to look at, but they're not a distraction. Even after we have performed all this tag filtering, we still have some values near the top that we'd prefer to be sorted out automatically. Many tags are correlated in ways that are obvious, with some level of process knowledge, and are not likely to be the root cause of issues that we see. What we really want to know is which tags have changed in unexpected ways. We can achieve this by creating a PCA model based on our baseline period. A PCA model is a linear model that maximizes variance with the fewest variables. If we want to build our model from within the deviation tool, then the first step is marking tags that we want to include in the model. We mark these tags with an X in the PCA column. And for here, we'll mark all of our tags. In the configuration window, under the PCA tab, we also have the option to bulk include tags under PCA. After we have marked the PCA tags, we click the option to recalculate the baseline hourly averages to be used for the model. The sheet will automatically remove tags from the model that have a low coefficient of variance because these type of tags have a poor effect on the model. Again, we'll skip through this calculation in interest of time. And we see that a data normalized sheet is opened automatically. This is the data normalized sheet that the add-in uses to pull in data. Next, we'll go over to the Data Park tab, and that is the data normalize button that we could have used to create a data normalized sheet, just like what we're doing here. And then the next step in creating the PCA model is we go into the Data Park tab and click the Park Model button. Our process is not grid or phase-based, and so we check those off. Everything else is filled in automatically. And then we can click the Launch button to create our model. We get a new window. Our model here, let's see, we give our model a project name and model name after we save it. The project name should match the name of our deviation detection display. And the model name is whatever we want to call the model. So we want to rename our display to have that same name, Steam. And then we want to go into the configuration menu. And under the data tab, we enable those last two statistics based on the PCA model. And finally, we want to recalculate the statistics for one of our comparison periods. Before we look at the PCA statistics on the deviation detection tool, I want to give you some insight on what each of these statistics means. So this is a representation of our SD change that we looked at originally. It's our standard control chart with a upper and a lower limit. This is what our deviation detection tool is trying to achieve when it calculates our d mod x statistic for us. D mod x stands for distance to the model in x space. This tells us how far away our comparison period is from our model. And so we can see that the limits sort of track the current track the overall process. And we only see deviations that are separate from the process itself. Hoteling t-squared gives us a different picture of the process. It tells us where our entire process deviated from the expected values. So we jump back over to the deviation detection sheet. We let it finish calculating. If we sort by the d mod x statistic, we see that it does not quite match up with either the percent change nor the SD change columns. Some of the tags have a high d mod x and a small percent change, because although the tag may be in the same range as the baseline, the value is expected for the process when it is in the current state. Some other tags had a high percent change, but have a small d mod x, because although the tag value changed, the change was expected due to the shift in the process. If we instead look at Hoteling t-squared, it describes how much a tag's change contributed to a predictable change in the process. Hoteling t-squared is less helpful for finding individual tags that are having issues, but is more helpful for diagnosing the cause of larger shifts in the process. So the last question that we want to answer is, how can you use the deviation detection tool? The deviation detection tool works with PARCview 5.6 as well as our new 7.0 version. The tool is included with a Park model license. We already have it in place with several customers, and if you're interested in trying out this tool as well, then you can contact us to be one of the people who get to try it out first. With that, I'll turn it over to questions.
Great, thank you, Neil, for going over that with people. We did have a couple questions, but I think mostly right now, so a few more come in. We actually answered them all with your last slide. So for those out there, it is available for 5.6 or 7.0. We are currently licensing it with Park Model. But also, I think his last line is important to contact your salesperson, your area manager, us, and talk to us about it and find out how you could use it. So one question, Neil, is kind of how does somebody use this on like a daily basis? What would you say? You know, it's I show up in the morning and what do I do with this tool at the beginning of my day to look at something?
Yeah, so I would say that you would start off following basically what this video is when you first set up this tool and get the process set up how you'd want it set up. And then each day you would go and recalculate a new comparison period, and you could see how the process had changed that day, and you could see how that changes on a day-to-day basis. And that'll help you catch small changes in the process before they become bigger issues, and will help solve those sorts of problems. We also are still in development of this tool. It's a pretty new tool, and one of the things that we want to get working real smoothly, it already works in some state, but we want to get it so it's very easy to use, is a sort of report that will generate on a daily basis and give you those same sort of updates, and just give you essentially what is a screenshot of this tool on a daily basis, or a run basis, or whatever basis that you would like to see the changes in the process.
Right. So maybe something that's showing the top 10 things every day. But isn't it also still important, even when you look at the top 10, to scroll down the list and see what other things are doing too, in case there's some anomaly that doesn't make sense?
Yeah, sure. To really understand what this tool is telling you, it requires a little bit of process knowledge to know which changes are important. And the first big 10 changes are probably ones that you want to look at. But like you said, you probably want to go through and look at some of the other tags that might have changed, just to get an idea of those small changes, like I was saying, get a good overview of what's happening with the process.
And that's what the ranking's for. So sometimes if you see things that are just always going to deviate, and they're known, that's when you give it a C or something and let it fall down in the list, but not removed.
Yeah.
So one question is about is any of this data going into our database that might be SQL tags that could be used for trending? Is that another possible option, or?
Currently, none of it is going into the database as tags. I certainly think that that's an option. I don't think there's any reason you can create a SQL template that's generated based on that. If you save a configuration of this display, then it's saved to the database, and the time period averages that you calculate are saved to the database. So yeah, that's certainly a possibility.
Another question is, would you have one sheet for the whole plant, or one sheet for each process?
Yes, so it's similar to a center line, how you'd set it up. You want one sheet for a process. The only real difference between configuring this tool and configuring a center line is that you're going to have a longer list of tags, so that you can get a better idea of those small changes in the process, things that you wouldn't normally look at in a center line, but are brought to the top by this tool.
And kind of like I think you mentioned, one of the purposes is not necessarily to handpick the list, just put everything in there, because you don't know for sure what might be changing.
Yeah, there's kind of two different ways that you can think about using the tool that are useful in different circumstances. You can dump in a huge list of tags, like I had said, from an entire process area, and get an idea of what's changed in the process, even if it's something you wouldn't normally ever think to add. On the other hand, it's a pretty easy to use tool, and if you want to just see what's changed between two specific time periods for just a short list of tags that you normally look at and just get a more detailed view of what's changed, then you can also use it that way too.
So somebody asked, based on that, is there a limit or practical limit on the number of tags that you could put in a process area?
There's certainly a technical limit in that it's in Excel, and there's 1,200,000 rows or something like that in Excel. So that would definitely be the maximum amount.
Yeah, hopefully it'd have less than that.
Trying to slow down a bit before that, but I don't see any other hard before that.
So really. It's more processing, number crunching that could be the limit.
Yeah. At one of the sites, we've had up to 3,000 tags in it, and that seems to work a bit slow.
Somebody's asking if they select a process, will it include the children of that process if it's trying to build the list based on a process area?
Not currently at the moment.
Okay. That's part of the reason we put it out there, is to let people.
Yes, feedback is very appreciated at this moment in the tool's lifetime.
Yeah, like you said, it's been sitting with some people who, in a way, were pretty integral in developing it. So they're also in the bubble that we are of used to it and not seeing other tweaks we can do. Somebody else says that you mentioned it was looking at hourly averages, kind of basing things on that, because we're not looking for like really kind of instantaneous changes, but more drift. But is that configurable? Could you look at set up different time period basis?
Yeah, it's a little bit limited right now. Right now, the two options are either hourly averages or 1 minute averages, because it's using the data normalized sheet, and those are the two easiest things to configure. And that covers both scenarios. Either you want kind of granulated times, reduced data density with 1 hour averages, or you want all the data, which is pretty much 1 minute data for most processes.
Okay. I'm right now not seeing any other questions coming in. So I guess the main one goes back to what people asked in the beginning is, like you said, it works with 5, 6, and 7. And if people are interested, just reach out to us and talk about getting it at your site, or giving you a chance to dig a little deeper into some of its features and the way it works as well. Otherwise, Neil, thanks for joining us and putting together that presentation and taking the time for some Q&A.
Yeah, thank you.
Well, that wraps up the first day of training, and we will be back tomorrow. You'll have Adam Cooper up here in the moderator spot, and we'll have 4 more presentations covering our asset manager. You'll learn about a little bit what Neil mentioned with Park Model, PCA, PLS models with Richard Chinnis. I'm forgetting the middle presentation, but then we're also going to have Molly Caldwell, who you saw at the first day of it, and she's just going to go over some neat tricks and tips about PARCview as well. So asset manager, Park Model, yes, Wayne McAdams with WPF bindings and Park graphics, and Molly getting into some tips and tricks in PARCview. Now, the asset manager one, that will be a 7.0 dependent presentation, but the Park Model is 5.6.7 compatible. Wayne covering graphics and WPF bindings is also 5.6.7.0, and Molly will be a mixture, and she'll be calling out what version any of the little snippets she's going to be showing you in the final presentation. So again, thank you everybody for joining us today, and look forward to being on the other side of the Q&A session tomorrow with Adam. Everybody have a good day, good night, or good afternoon. Thanks.